All right, it says, what is the osmotic pressure of 2.75 liters of solution containing 18.1 grams of KCl at 25 degrees C? And then it gives us the molar mass of KCl. So this osmotic pressure is a rearrangement, if you will, of the ideal gas law. So pi, the osmotic pressure, equals I, the Van Hoff factor, which you've seen before, times C, which is the concentration in molarity, moles per liter, times R, the ideal gas law constant, 0.08206 liter atmospheres per mole K, times T, the temperature in Kelvin. Okay, so pi, the osmotic pressure, equals the Van Hoff factor times the molarity, moles per liter, times the ideal gas law constant times T. So it's essentially a derivation of PV equals nRT. This is P, this is N and V, this is R, this is T, and then I is, because it's a colligative property, we need to account for how many things are in solution. So again, there are several things that we need to find. Specifically, we need to find I, C, and T because R is a constant, and so that's basically that. So for I, if you haven't already watched the previous question where we go over the Van Hoff factor, please do that first. We have KCl solid, which breaks up into K plus, a 1A metal, and Cl minus, a 7A nonmetal. So I is equal to 2 because one of these dissolves into two things. For the concentration, here we're using molarity, not molality, so moles per liter. So to do that, we want to go from grams of KCl to moles of KCl, and then we want to divide that by the liters of the solution. So we start with 18.1 grams of KCl times, put the molar mass on the bottom, 74.55 grams of KCl on the bottom, and 1 mole of KCl on the top, times unitless 1, that moves the moles over, and then the volume of the solution in liters, which is already given in liters, so divide by 2.75 liters. When you do that, you find that this is a 0.0883 molar KCl solution. So we now have the Van Hoff factor and the concentration. R again is a constant, and then the temperature just has to be in Kelvin. So we want to take the 25 and add 273, so we get 298 K. We now have everything we need. The osmotic pressure equals I, 2, because it broke up into two things, times the concentration, the molarity, which we just found, 0.0883 molar, times R, 0.08206, that's a liter atmospheres per mole K. I might as well write it because I'm only doing it the one time. I guess it's in the next question too, okay? And then the temperature is going to be your 298 K. And when you do this, you find the osmotic pressure of this particular solution is 4.31 atmospheres. So this is how you would determine the osmotic pressure of a solution.